In this lecture, we find the domain of certain functions. The domain of a function is generally the largest possible set of inputs into the function. So for example, let's find the domain of the function f of x is the square root of x. It is often easier to ask the question, what is not in the domain? For the function f of x equals square root of x, let's ask this question, which real numbers do not have a square root? We cannot evaluate f of x at negative numbers since the square of any real number cannot be negative, so a negative number cannot have a square root. So the domain here must be numbers which are not negative, that is 0 and positive real numbers. We can take the square root of 0, so we want to make sure to include 0 in our domain. If we write this in interval notation, the domain is the closed interval from 0 to infinity, open at infinity, since infinity is not a number. So this includes 0 and everything to the right of 0. Let's find the domain of the function g of x is this expression, a rational function. What numbers cannot serve as input to g of x? Again, when asked for the domain of a function, think instead of what should not go in the domain and make sure to exclude that. Here, we cannot have denominators equal to 0, and so when x is minus 2, we would have a denominator at 0, so that cannot be an input. Also, we cannot have x equals minus 1/2 as an input because that would make the second fraction have a denominator of 0. Those are the only two problems, so the domain of this function is all real numbers except x equals minus 2 and x equals minus 1/2. There are several ways to write the domain of g. Using set notations, I could say that it's the set of all real numbers x with the property that x is neither minus 2 or minus 1/2. That's a precise way to say all real numbers except minus 2 and minus 1/2. But we can also write it in interval notation by excluding minus 2 and minus 1/2. This expression, open interval minus infinity to minus 2, means that all real numbers between minus and 2 and minus infinity are included. All real numbers to the left of minus 2. And then we'll union that with the interval from minus 2 to minus 1/2, all real numbers between minus 2 and minus 1/2. And then we'll union that with the interval minus 1/2 to infinity, in other words, all numbers bigger than minus 1/2. Anything in any of these three intervals will work, but notice that minus 2 is not in any interval, neither is minus 1/2. So this notation says that the domain includes all the real numbers smaller than minus 2, all the real numbers between minus 2 and minus 1/2, and all the real numbers larger than minus 1/2. Some worked exercises. Let's find the domain of the function f of x is the square root of x minus 1. Earlier we had said that a square root function requires non-negative inputs. So here we must have x minus 1 being non-negative. If x minus 1 is greater than or equal to 0, then x has to be greater than or equal to 1. So our domain is all numbers from 1 to infinity, including the number 1. Hard bracket 1 on the left. Let's find the domain of the function f of x is this fraction, square root of x minus 1 divided by x minus 3. In each case, when we're asked for the domain, you might think about what can't go into the domain. X has to be greater than or equal to 1 in this problem because we need to put in non-negative numbers under that radical sign. But we also have an issue of the denominator possibly being 0, so we have to exclude x being 3. If I look at this expression and I see that radical sign, I say x has to be at least 1 so that I don't put in negative numbers into the radical. And then when I look at the denominator, I say x can't be 3 because I couldn't have a 0 there. So our domain is in all real numbers at least as big as 1 except for the number 3. In interval notation, it looks like this. Hard bracket 1, comma 3, soft bracket means all real numbers between 1 and 3, including 1, but not 3. And then we union that with soft brace 3 to infinity. That's all real numbers bigger than 3, not including 3. One more problem here. Find the domain of this function. This radical in the numerator says we have to have x at least equal to 1. But we also must prevent the denominator from being 0. If I factor the denominator, I get the denominator is x minus 2 times x minus 4. So if x were 2 or x were 4, the denominator would be 0. So we have to rule those out. So our answer is all real numbers at least as big as 1 to make the radical happy, and not equal to 2 or 4. In interval notation, our answer is this expression. It's the union of three intervals. The first interval, close bracket 1, soft bracket 2, is all real numbers between 1 and 2, including 1 but not 2. And then we allow the interval from 2 to 4, all real numbers between 2 and 4, not including either 2 or 4. And then finally, the last interval, all real numbers bigger than 4.